Assalamu alaikum dear students, you are watching Study with Sheraz, and in today's lecture we are going to talk about the radioactive decay. So first of all we will define that what is radioactive decay. So disintegration of parent nuclide into daughter nuclide with the emission of radiations is known as the radioactive decay. Basically, radioactive decay is a process in which a nuclide that is unstable in nature is converted into another nuclide by the emission of certain particles and radiation, and this process leads to the stability of the nucleus. So the nucleus that is changing is called the parent nucleus, and the nuclei that are produced as a result of the change are known as the daughter nuclide. So there are many types of the radioactive decay. Some of the most important processes are mentioned here. So first of all, the most important type of the radioactive decay is the alpha decay. So it's basically the emission of alpha particles from an unstable nuclei, and that leads to the decrease in mass by 4 units and charge by 2 units. In whole of this topic, the most important thing is that you must know that how a particle is produced, what changes are produced in the parent nuclei while a decay process occurs, and what is the change or what is the effect of release or the decay on the atomic mass and atomic number of the parent nuclei. By considering these things, you can predict the atomic number and atomic mass of the daughter nuclei. So if we talk about the alpha emission, you people know that alpha particle is basically the helium-2 4 nuclei. Of protons is 2 and the mass is 4 units. So whenever an alpha particle is released from a nuclide, the mass of the nuclide decreases by 4 units and the charge decreases by 2 units. So the daughter nuclei that is produced would be having 4 units less mass than that of the parent nuclei and the 2 units less charge than that of the parent nuclei. So we can represent the alpha decay by a hypothetical equation in this manner, in which we consider that X is a nuclide having atomic number Z, atomic mass E. If it undergoes alpha decay, its atomic number would be decreased by 2 units, whereas that of the mass would be decreased by 4 units. 2 shows the release of energy, because a lot of energy is released that is accompanying the alpha decay. Some of the energy is given to the daughter nucleus and some of the energy is given to the released alpha particles, and because of this energy, alpha particles move with a very high speed away from the other nuclei. Nuclides with atomic mass above 83 undergo alpha decay because alpha particles are highly massive particles. So the nuclei that are having large atomic mass or the atomic weight undergo alpha decay to decrease their atomic mass in order to gain maximum binding energy. So example here is given the uranium 92-38. So its atomic number is 92 and the mass number is quite large, and in order to decrease its mass number, in order to gain the stability by decreasing the mass number, it undergoes alpha decay, and as a result of the alpha decay, thorium 90-34 is produced with the release of alpha particles. And you people can look here that the atomic number of the daughter nuclei is 2 units less than that of the parent, and its atomic mass is 4 units less than that of the parent. The next most important type of the decay is the beta decay. As you people know that beta radiations or the beta particles are actually the fast moving electrons, but when they are acting as the beta particles during the beta decay, these are formed at the time of emission by conversion of neutron into proton. As you people know that there is no concept of the electrons within the nucleus. but the beta particles are produced from the nucleus. So how it's possible that electrons are released from the nucleus? Basically, during the process of beta decay. These are produced at the time of their release, and how they are produced by the conversion of a neutron into proton. So atomic number increases by 1 unit, but the mass number remains same. So as a result of the beta decay, the atomic number or the charge of the nuclei increases by 1 unit because a neutron is being converted into a proton, but the mass remains same because the mass of a proton and neutron are almost equal. Earlier we talked about the how a neutron is converted into the proton. So neutron can be converted into proton with the release of the beta particles, beta minus plus nu minus. This is basically showing the antineutrino. These are the particles which are having negligible mass and no charge. These are basically produced to maintain the momentum of the system. So neutron is having, so charge and mass both are balanced by this equation. So we can represent the beta decay through this equation, hypothetical equation, in which X is a nuclide having Z atomic number, A atomic mass, and when it undergoes beta decay, its Z increases by 1 unit, whereas A remains same, plus beta minus and nu minus plus Q. So energy is also released as a result of the beta decay. Example here is the carbon 614. That's an isotope of the carbon, and it undergoes beta decay in which its atomic number increases by 1 unit, but the atomic mass remains same. And the element having 7 atomic number is nitrogen, so it's nitrogen plus beta minus. So this is about the beta decay. The next is the positron decay. Basically, positrons are the particles having mass equal to electrons, but their charge is opposite to the electron. You can say that they are having +1 charge. So also formed by conversion of proton into neutron. Basically, beta decay and positron decay are almost related to each other. They are almost the reverse of each other. During the beta decay, the charge increases by 1 unit, but the mass remains same. During the positron decay, mass remains same, but the charge decreases by 1 unit. Beta particles are also produced during at the time of emission. In the same way, positrons are also produced as the time of emission. So these are produced by the conversion of proton into neutron. So atomic number decreases by 1 unit as a positron is having +1 charge. So as a result of the positron emission or the positron decay, the atomic number decreases by 1 unit, but mass remains same. So P converted into N plus beta plus. In many books, both of these are discussed under the heading of the beta decay. It's called the beta minus decay, it's called the beta plus decay, because positron and beta particles are having same mass but opposite charge. Here, nu, and other small particle, it was the antineutrino, nu minus, and it is the neutrino or nu. It's also released to maintain the momentum of the system. So hypothetical equation that represents the positron emission is the xz into a n. As a result of the positron emission, z decreases by 1. A remains same, beta plus is the positron plus neutrino, and energy is released as a result of the positron emission. An isotope of the oxygen, O815, undergoes positron emission, as a result of which its atomic number or its charge decreases by 1 unit, but the mass remains same. 15 is same as that. So the element with 7 atomic number is nitrogen. So again, another isotope of the nitrogen is formed, and beta plus, that shows the release of the positron. The next is the gamma emission. As you people know that gamma rays are not the particles. They are just the electromagnetic radiations having no charge and no mass. So excited nuclei release extra energy as beta radiations. Sometimes the nuclei are excited. So the excited nuclei are having high energy content and they release their energy content. They go to the ground state by releasing their extra energy in the form of the electromagnetic radiations as the gamma radiations. Because the gamma are having no charge, no mass, so there is no change in the atomic mass and atomic number of the nuclei. The only change is that the nuclei become stable as a result of the gamma emission. So X, Z, A and asterisk is shown. This asterisk is showing the instability or the extra energy or the excited state. So as a result of the gamma emission, the charge and mass has remained same, but asterisk has been removed because the nuclei has been converted into the stable one. And the last process is the electron capture. As the word indicates, in this process the nuclei capture the electron. In most of the time, it is an orbital electron of its own, during which the K shell electrons are captured by the nuclei because they are closest to the nucleus. So nucleus captures electron to convert proton into neutron. So the nuclei that are having less number of neutrons can convert their proton into neutron by capturing an electron of its own. And during this process, the positive charge or the atomic number decreases by 1 unit. As you people see here, P plus electron gives us the neutron plus nu. So nu is showing the release of the neutrino. Mostly K shell electrons are captured, so it's also called the K capture. Because K shell electrons are captured as I explained earlier, so it's called the K capture. So X, Z, A plus electron, and whenever it would capture an electron, the atomic number would decrease by 1 unit because the proton is converted into the neutron, but the mass has remained same because the mass of the proton and its neutron are same. So this was all about the radioactive decay. We will meet in the next video. Up till then, Allah Hafiz.